Hello and welcome. In this video, I'm going to take you through all of the equilibrium practice problems that I've gone over with my students in class and some additional practice problems that sometimes we have time to do in between the formal lecture. So these are work problems for practice and understanding. I'm not going to work it through with a pen or pencil like I normally do. It'll be through slides, but go ahead and pick up your calculator and follow along. Our first problem here, we're asked to write the equilibrium expression for this reaction here. Remember that the equilibrium is products over reactants. So our first product is hydrogen, H2. Our second product is CH2O, called formaldehyde. And then that's divided over reactants. CH3OH is methanol, that's a reactant. And platinum is a solid. We don't put solids or liquids in the equilibrium expressions. More on that later. Practice problem number 2. We have an equilibrium expression for, well, this is not a platinum catalyzed reaction, but anyways, it's products over reactants. So let's look at this. Our first product is sulfur trioxide, but we have a coefficient of 2 in front of this substance, so we need to square the concentration of sulfur trioxide. For reactants, we have SO2, or sulfur dioxide, but there's a coefficient for 2, so we need to square the concentration of sulfur dioxide. Our other reactant is oxygen, so we place that in the denominator. Here are some more practice problems. You can pause the video and work on these and see if you come up with what I come up with. Some of these are tricky, and I'll take you through them. For A, we've got a solid in a couple different spots. My tip for you is to replace the solid substances with the numeral 1, or just the 1, okay? So as usual, we have products over reactants. Our first product is sodium oxide, which is a solid, so just put a concentration of 1 there. Don't even worry about squaring the 1. Our second product is carbon dioxide, which is a gas, so we put that in the equilibrium expression. And our reactants are solid, so we've just put a 1 there. So when you simplify this, it just comes out to the concentration of carbon dioxide. The next problem here is part B. We have a liquid in the equilibrium, so my tip to you is to replace liquid substances with 1. So our products are going to be carbon dioxide, and well, that's carbon monoxide, and we square that. That's a typo there. Hydrogen is to the 5th power. For the reactants, we have C2H6. And water is a liquid in this chemical reaction, so we just replace it by 1. I've squared the 1 there, so you can see that. When you simplify this, it just drops out, okay? So carbon monoxide squared, hydrogen to the 5th power, divided by C2H6. For part C, we have, again, products over reactants, and everything here is a gas, so no tricky business. We have ammonia to the 4th power, oxygen to the 5th power, so those are all products on the right-hand side. Our reactants are NO to the 4th power and H2O to the 6th power. Here, H2O is a gas, so it is in the equilibrium expression, so watch out for that. Next reaction we have, it's rather tricky. We want to replace both liquids and solid substances with 1. So let's get started. Equilibrium is products over reactants. So the product is a solid, so we just replace that with 1. Our first reactant is ammonia, which is a gas, so we place that in brackets. And HI is a liquid, so we replace that with 1. When you simplify this, it just becomes 1 over the concentration of ammonia, or 1 over the pressure of ammonia if you're talking about Kp. What if we have a problem like this? We're given the equilibrium expression, but then we're asked to write an actual chemical equation or chemical equilibrium that describes the reaction. Well, here we just work backwards. So remember again, the equilibrium expression is products over reactants, okay? So the reactants, what you start with is in the bottom of this fraction. So we start with 4 NOs, and I'm just going to assume everything's a gas here. H2O is, well, we have 6 of those, right? And that's in equilibrium with 4 ammonias and 5 oxygens, okay? And everything's gas there. There's no solids or liquids, we know. I'm assuming that everything's gas because we're in this, equilibrium, gaseous equilibrium chapter. Let's do some problems now. So for this, you'll need a calculator. We want to calculate Kp for the following equilibrium. So we got NOBr, NOBr2, and we have various pressures here in units of millimeters of mercury, okay? Step 1, we want to write out the Kp expression for this reaction. Again, it's products over reactants. So carefully write out the products. We have NO, which is squared, times bromine. Okay, those are the products, divided by NOBr squared, because that's the reactants, all right? And then step 2, we want to plug in the pressures, okay? So 3.5 squared times, it looks like 12, divided by 20 squared. So grab your calculator and do that. I get 7.4 when I do the math, and the equilibrium constant will never have units, so just leave them off, okay? How about this problem? We're asked to calculate the KEQ, or the equilibrium constant, for this chemical reaction. And in this problem, we're given all the equilibrium concentrations as noted. Step 1, write the equilibrium expression. It's always products over reactants. So hydrogen and iodine are products, and hydrogen iodide, or HI, is a reactant. Make sure the HI is squared, okay? You'll see here in the math that I didn't write down the squared. So 0.0058 times 0.0058, and then you want to divide by 0.0072, square that, okay? And I get 0.65, okay? So there should be a squared after the 0.0072. And this answer is not correct. It's 0.649, or 0.65, okay? So please correct that as we're going through. I do not have a desire to redo the whole video up to slide 53 to correct that. So please take note. What happens if you have a missing concentration that you need to solve for? So we have this chemical equilibrium, and we're given the equilibrium constant. And we're given a couple of different concentrations, and we want to know what is the nitrogen concentration. As usual, you want to start out by writing the equilibrium expression, and very carefully keep track of the coefficients. These are going to be powers, right? So we have NCl3 squared divided by chlorine cubed divided by nitrogen, okay? And so what we want to do is solve for N2, because we're trying to find the nitrogen concentration. So this was the previous expression, so we want to solve for N2, so we can just swap KEQ and N2 in that formula. And then so we have N2 is equal to NCl3 squared over chlorine cubed KEQ. Okay, so then what you want to do is plug and chug, okay? And here I'm correctly using the powers, so 2.5 times 10 to the minus 6 squared, okay? Divided by 1 times 10 to the minus 3 cubed, and we divide by the KEQ. So you want to make sure that you're putting in the right numbers for the right concentrations here, and you're cubing and squaring correctly. When I do this, I get 0.42, okay? Do you see this expression? I'm sorry, do you see this expression here? I just have single parentheses. If you are not getting 0.42, you might be using a TI series calculator, and you need to insert an extra pair of parentheses on the bottom fraction, okay? And that usually fixes the error, and you'll get 0.42 on your calculator. All right, let's do an additional practice problem. Here we're asked to calculate the pressure of hydrogen. So hydrogen is a reactant, and the other two chemicals are gases, and we have pressures for those two, and we have an equilibrium constant. So we're basically solving for just hydrogen. So step 1, write out a Kp expression. It's going to be products over reactants. Make sure you're squaring the hydrogen because there's a 2 in the balanced chemical equation. Solve for Kp. So what you want to do is basically swap the location of the Kp and the hydrogen squared, okay? So hydrogen squared is going to be methanol over CO divided by Kp. Let me activate the lights here. All right. And now what we want to do is plug and chug, so to speak. So we want to plug in all these values here, okay? And what I get on my calculator is 0.100. Nice kind of simple decimal there. Now, this is not hydrogen, it's hydrogen squared. So don't forget to take the square root of the hydrogen concentration, hydrogen pressure, so we get 0.316, okay? And that's going to be in units of atmospheres, because in the very beginning of the problem, we had atmospheres for the chemicals, okay? So that's it for this video. I hoped I didn't rush through these problems too quick. Pause and work and see if you can get the same answers I have. And thanks for watching. Please like, give a thumbs up, and consider subscribing to my video. Take it easy.